The circumcenter of a triangle is the center of a circle which passes through the three corners or vertices of the triangle. This circle is called the circumcircle of the triangle. Now the circumcenter doesn't have to be inside the triangle. So you can see here that the circumcenter of this triangle is outside. Let's see how to construct the circumcenter of this triangle. We need to get the perpendicular bisectors of any two sides of this triangle. So first I will get the perpendicular bisector of this side of the triangle. Now, we explained how to do this in a previous video, but I'll go through it again. We draw a circle centered at one end of the line and whose radius is more than half the length of the line. Next, we draw a second circle with the same radius as this circle but centered at the other end of the line. The perpendicular bisector of this line passes through the points of intersection of these two circles. Next, we get the perpendicular bisector of one of the remaining two sides of this triangle. It doesn't matter. So let's get the perpendicular bisector of this side. So again, we draw a circle centered at one end of the line whose radius is more than half the length of the line, and we draw a second circle with the same radius as this circle but centered at the other end of the line. The perpendicular bisector of this side passes through the points of intersection of the two circles. The point of intersection of the two perpendicular bisectors is the circumcenter of the triangle. Now, since I said we only have to get the perpendicular bisectors of just two sides of the triangle, it must be the case that the perpendicular bisector of the third side also passes through this point. So the three perpendicular bisectors of a triangle are concurrent at a point called the circumcenter. We will prove that the three of them are concurrent in another video. For now, let's get the perpendicular bisector of the third side. Now, since the circumcenter is the center of the circle that passes through the three corners of the triangle, it must be the case that the distance of the circumcenter to each of the three corners is the same and is equal to the radius of the circumcircle. So to draw in the circumcircle, we just put the compass point at the circumcenter and open up the compass to one of the corners, and it'll pass through all three of them. Notice that when the circumcenter is on one of the sides of the triangle, then one of the angles is 90 degrees, or appears to be 90 degrees. Notice that when the circumcenter is on a side of the triangle, then the side of the triangle must be a diameter of the circle, and the line segment indicated with the three dashes must be a radius of the circle. Since this side is a diameter of the circle, we see that the angle up here is the angle in a semicircle, and we saw in a previous theorem that the angle in a semicircle is 90 degrees. The reason being is that it stands on the same arc, this semicircular arc shown in red, as the angle at the center. Now the angle at the center is 180 degrees because this line is the diameter of a circle, and from an earlier theorem we know that the angle at the center is the angle at the circle is half the angle at the center. So half of 180 is 90 degrees. So when the circumcenter is on one side of the triangle, then we have a right angle triangle.